All right, let's get started. So thank you everybody for joining today's webinar on world models for physical AI. We are super excited to have you all here. So we are Oscar and Jen from the solutions team. A quick introduction seems a fitting way to start. I'm Oscar and I work on the solutions team, which basically means we work directly with our customers, seeing their applications, how they're leveraging Encord, and we'll go into more detail of what that means later on for those of you who don't know. And yes, we see hands-on how customers are using Encord to build out physical AI systems and agentic AI too. Joined here as well with Jen, who I'll now let introduce herself.
Thanks, Oscar. Great to be doing this webinar today with you. Really excited to share some of the insights we've heard on the ground from some of the partners we work with in the physical AI space in today's webinar.
Fantastic. Likewise. So what we'll do to kick off with is go through the agenda for today's webinar. So you can see at the top, we're going to cover what world models are, start off with an introduction, and see what the difference between language models and world models are, the differences and the extra functionalities that we get. We'll discuss how this applies in particular to physical AI, and also why human in the loop is key. And so we'll really touch on the importance of human oversight to ensure that we have alignment for these systems and also as part of the training flow. Then we'll dig into the requirements for agentic AI and some of the kind of business applications for that as well. And then we'll go into a live demonstration of the Encord platform and cover that, followed by some Q&A. Brilliant. And as we said in the previous slides, if you do have any questions during the session, please post them in the chat and we can take them at the end. Awesome. So to start with, just a very brief introduction into Encord. So Encord is a MLOps tool. We basically enable you to do everything on your training data layer. And so this can inform everything from data management, going from raw unstructured data, to imbuing context, including adding agentic annotations, automating these processes, doing human in the loop validation. We also do preference ranking, ground truthing in this interface as well, and can provide kind of workflows, which we will go into more detail later on into how to set these up. And then active, which enables us to validate the quality of these models. And all of this is integratable with external systems too via our API as well. And so really excited today to go through how our current customers are using some of our tools to help solve these problems in the real world for both world models and physical AI systems. Fantastic. Right, let's jump into it. So Jen, to kick us off, would you mind introducing world models for the call today?
Absolutely. It's one of these buzzwords that has really been popping up all over the place over the last year, alongside other trends that we see in the space, like agentic AI or multimodal AI. But like some of these other concepts, these are a really exciting research direction, but it's been a bit harder to understand and practice what this actually means and looks like. We see that there's been quite a bit of progress in world modeling, though, in the past few months, with the release of Genie 2 from Google DeepMind, this large-scale foundation world model. And we see Jan LeCun in particular as one of the AI leaders who's been most outspoken about what world modeling could offer as a next step in the AI field. I think we're seeing a few key ingredients for world modeling that different people are converging on. One is that it is really important for world modeling that our modeling becomes multimodal. So going beyond the language layer and text-based modeling to all of these other modalities that we encounter in different environments and different worlds that we actually want our AI systems to be operating in. And that's the second ingredient that I think is really important to highlight. Instead of our models just living within a server or a compute environment, now our AI systems are now taking actions within an environment. So whether they're AI agents or AI systems embedded within physical AI or embodied AI, larger systems, we now have AI that is taking actions, interacting, and influencing the environment around them. I think another great output that Jan LeCun has shared is actually this social media post where he also breaks down some of the different inputs and outputs he sees as essential to what a world model needs. So we can see he's highlighted things like the ability to capture an observation that an agent has at a given time. So you want to be able to know the spatial and temporal information as well as the multisensory, multimodal input for that particular moment. We also want our world models to be able to represent different states of the world. So whether that's the current state, the past state, or a future state, they need to be able to represent that in some form. And then, of course, there's all the important features around being able to actually represent action proposals. So now that the agent has made an observation and understands a certain state of the world, what is it going to do next? And finally, we see another key element of world modeling is the ability to capture uncertainties, unknown information about the world that the agent might need more information on in order to take a correct action.
Awesome. Thank you so much, Jen. Yeah, I mean, it's when we first started discussing world models, thought, oh, we doing a specific webinar on kind of like geophysics and that sort of modeling. But no, this is very clear that what we're doing is when we're thinking about AI systems and we're looking at the kind of past, present, and then future, right? So we have this previous estimation of the state, the observation from today, and then the proposal going forwards, and kind of imbuing that degree of randomness that we see in world decision making in there too. And so many of these models, to be able to get this extra context, require to pull from various different modalities and different resources. And I suppose with the kind of transformers architecture at its base. And so seeing these LLMs as the kind of core, so we can see some of these headlines here about the future of generative AI and LLMs as well. I think it's important to maybe start this conversation in the language space, because this is basically where all of this progress started off originally. And yeah, so basically what is the difference between our language modeling approach with world modeling?
Yes, absolutely. So I think you make a great point, Oscar, that what we're really building upon is the foundation that all the great advancements in LLMs enabled. So many things to highlight. I think one thing, as you point out, in addition to the architecture, is this ability to handle really diverse input and output, starting with a single modality, right? But it's very cool that when we interact with LLMs, like through a chatbot or some other kind of interface, we can really ask anything, whether it's to write a poem or draft an email or to write a script. And it's able to respond to that diverse kind of input and respond and produce an output that makes sense and is relevant and useful for that different context. And I think as we move to different modalities, that is a key feature of LLMs that we will want to preserve. So we can imagine diverse content of all modalities as an input, and then diverse outputs coming out of our world models as well. I think another key thing that LLMs introduced to us is the value of having natural language as an interaction layer with models. So the ability to converse with models, to steer them, guide them, ask questions, and understand how they are thinking also through natural language, I think is a really key element that LLMs introduce that we will likely continue with world models.
Very cool. Yeah, so that makes sense. So we have the language as the kind of interface with these models and the interaction between them. But then what we have beyond that is basically being able to transform this across multiple modalities. But language not only acts as the interaction between the human and the model, which if these systems, these agents are acting in a space for them to have value, they'll probably be interacting with humans at some point. So language can kind of be this common interface, but also the language itself can form the kind of embedding. So rather than the numerical context, it will be storing this information in language embedding effectively. And then what that means is that we can capture all of the kind of fuzzy and diverse nature of the world around us rather than this sort of numerical storage. Awesome. Yeah, and so I suppose to kind of add some color to that, this is the traditional interface with language models, right? That probably everybody here on the call is very familiar with. And so going with from this familiar to the next level, if we move to this diagram where we're looking at a world model example, then Jen, talk us through the kind of core differences here, right? So we're seeing these multi-inputs and then these very interesting outputs. But yeah, can you add some color there?
Absolutely. I think just between these two slides, we start to see what the potential is here, right? We're really moving beyond the chatbot box into these new environments, whether they are simulations, video games as worlds, the internet as a world, or other actual physical spaces, such as streetscapes, factories, warehouses, the home settings where we know physical AI systems will be deployed. And this diversity of possible worlds that we need to model will also present a diverse number of challenges. The number of modalities that are relevant for these different cases might be very different, or at least the content will be very different. But what we want is to have this flexible architecture so that whether our inputs are text, like we just talked about, or potentially our inputs are images or audio files, we want to be able to use these modalities to then steer the actions of our agent in these different settings. And so you can imagine all of this becomes much more complex. We're not just asking for text out, we're actually asking these agents that are embodied to take actions in their environments, whether it's, as you can see in this quite cute example of this small embodied agent here, kicking, running, doing a headstand, doing the splits, whatever it might be, or actually changing the environment around them.
Yeah, that's so cool. And suppose that's kind of why we're discussing this in the context of physical AI today, right? Where we're thinking we need our systems that if they're to act in the real world and output these actions and not just diagnose, not just perceive, we need to be able to ingest more than just this text information. We need to be able to register data from such a wide range of sources to ensure that our systems have the right level of context to do this reasoning. And I think that's the kind of the key points that we wanted to make in the first part of today's presentation was basically just like to be able to have this degree of outputs and to be able to operate kind of safely as well. They need to be able to register information from so many of these different modalities to be able to make context and reason in the same way that we do when we're making our decisions. Hopefully better.
Hopefully better and hopefully safer too, if possible. So totally agree, Oscar. To realize the full potential of these agents in these real world settings, we'll need them to be able to process, understand, learn, interact, and do so in a way that is effective, but also safe.
Absolutely. I think when we were discussing the topics for this webinar and we were discussing world models, right? And then we saw this be released by Hugging Face, this any to any world model filter effectively. It was very like validating. And so yeah, it was cool to see this be released. Jen, can you kind of tell us more? What are these any to any models?
Absolutely. Yeah, it was really cool to see this any to any tag drop on the Hugging Face Hub last week. Definitely recommend those of you who haven't read their great post on vision language models or the any to any models to take a look. But essentially, what they've provided is this interesting framework to now filter for these multimodal in, multimodal out models. And I think as of the last time I checked, which was about an hour ago, there's almost 7,000 models now on Hugging Face Hub with this tag. So this any-to-any model capability isn't something particularly new, but it's really starting to explode right now. So this concept, of course, has been around a while. I think after we saw the initial success of LLMs and text to text, and people started thinking about other pairs, image to text, text to speech to speech, text to speech, you can see how this gets quite unwieldy very quickly if you were to do this pairwise input output for every possible modality. So I think this framework is very helpful as a research direction that the field is moving towards, right? Where what we want to build towards is the way that humans also operate in the world, which is we take in multimodal input, multi-sensor input, and then we do a lot of things. We produce speech, we write text, we take actions. And I think this is the direction that these any-to-any models are really moving towards as well. I think a few interesting things to highlight here too for what this enables. We're seeing some interesting trends with these any-to-any models. They are at the same time multimodal, but as the Hugging Face blog post points out, they're also becoming smaller. And that doesn't mean less capable. It just means that then you are able to run these new exciting multimodal models in more environments because they can run on more hardware. So we have these models that have a unified perception and action layer so that they can take that input and then react to it and learn from it all within one system. And because they are more performant and smaller and more efficient, what this also enables and is really exciting for the physical AI space is the ability to do things like real-time edge processing. So deploying one of these models in a remote or an environment with low internet or some difficult connectivity, all of these new opportunities expand when you are able to leverage this real-time processing at the edge.
Very cool. Very cool. Yeah, and interesting to see not only the range of modalities changing, but also the different architectures and the ability to work with these on the edge, which again, that the kind of latency gains from having lighter models and being able to work with them in real time is also relevant when we're looking to interact with them as humans. You know, if I'm looking to get an Waymo and it takes me somewhere, I don't want it to be stalling at lights, I don't want it to be delayed. If I'm using a web agent to order my Uber Eats or whatever it is, then I want that to be faster than I would be and perform, and so be able to ingest all of this information quickly too. So that's all kind of super important as part of this as well. But I guess when we're thinking about making these systems operate safely, I think like human in the loop was the next part that we wanted to touch on. And so why, if we have these systems that are starting to take actions, then making sure that they're behaving in alignment with our intentions and with what we deem to be safe and fair is so important. And so, Jen, why in particular, when we're thinking about agents and physical AI, is human in the loop so important?
Yeah, I think you framed it well, Oscar. As these agentic systems or AI systems are deployed in more context and taking actions, whether it's making orders for us or driving or operating certain vehicles or making decisions, it becomes way more important. It really raises the stakes for that human supervision, especially as these models are still in development. So maybe we'll get to a point eventually where we have more trust, and this is something that we don't need to have such a close eye on. But especially in these early days where we're starting to see different systems deployed in real world settings, having a close eye on how they're operating and improving their learning and training and improvement is really important. So more than ever, in this world modeling space, human in the loop remains essential. And there's a few trends that we're seeing in this space for what human in the loop work looks like now. It isn't as simple as it was before, where maybe we had a content moderator flagging whether something was appropriate or not, or someone was fixing a bounding box edge. That isn't what we really mean by human in the loop anymore, though those are still things that are very valuable. We're seeing that to meet this world modeling demand, human in the loop is becoming multimodal. So Just like the systems need to be able to work with these modalities, any sort of data interface or data tooling also needs to be multimodal to match the direction that the models are heading. The purpose of human in the loop is also becoming more multi-purpose. So one that we've touched a lot on quite a bit now is the value of supervision. So as agents make more real-time decisions, some of these may be critical, or some of these may need more human oversight than others. So having the human in the loop to do something like an approval, a review, a double check, a sanity check is really important. We also see some interesting use cases in the post-training space as we think about things like preference optimization or gathering human feedback, RLHF. We see this human in the loop role starting to rise as a way to help in the post-training process. And finally, we see that human in the loop is becoming much more multi-stakeholder. So the who that is involved in the loop is also broadening beyond the ML researcher or engineer or the data annotation expert or data worker. We are now seeing a broader range of people needing to get involved. So some of these groups include domain experts, so people who have a specialization in the environment or the system that the agent is operating in, or maybe they're experts in radiology or experts in the robotic form factor. These people also need to be brought into the loop. So designing good interfaces that people from all backgrounds can work with well becomes really important.
That's yeah, that's super interesting. I love that. I love that the who is diversifying and the loop is broadening as well. Like we're looking at a lot of different multis on this frame, but essentially when we're thinking about these problems, it's that the complexity is increasing, and the purpose is maybe becoming more important and having more impact and more dependency. And so we need to be able to efficiently bring in people from an array of different sources to make sure that these are aligned as well. And so I guess next, we want to introduce why we care about this so much at Encord. And so basically we have this concept of data agents, which allow you to orchestrate in workflows and in pipelines this combination between models and also our human agents to kind of go in and validate the outputs of those and input some extra context, some extra knowledge to help improve the quality of these systems as well. So when we're thinking about that first multi on the multimodal, there are some problems that are solved that we can leverage tooling for to extract the relevant information from the data. And then there are some problems that are solved for creating connections between this extracted data. But then we also need humans to improve this and enrich these fields to basically ensure that our models can exist in broader instances. So we can see a couple of examples here on the bottom left, where we have, if we had an agent that was classifying, for example, damage on a car, right? And we can see that we have these two images from a vehicle, and then we have a report on the right-hand side. This is kind of imbuing this additional context to be able to reason and make these decisions. And then on the right-hand side, if we have a kind of customer help conversation or transcript, being able to interact with not just only our audio models, but also the vision to engage the emotion, the sentiment, and then also the language field as well. And how this looks and how we kind of help here is by being able to orchestrate these different workflows. So, Jen, I think when you were describing the different kind of multis that are involved in this process, then the proposition was that as these models get better and improve in quality, then basically the amount of human interaction will decrease, right? But so we have this idea of human in the loop or maybe model in the loop, depending on which one the emphasis is on. But either way, we provide a way to orchestrate both the models and then also the human interactors to kind of add this extra context in one pipeline.
For sure. And really the design principle here is to bring the humans into these complex pipelines where it makes sense, where it makes the most sense to bring the humans in. So for some tasks at this point, like pre-processing data, transcription, sorting, these are things that should not to require human attention. There are things that we can automate. That way, the human time, the valuable human time, can really be spent on the most important tasks.
Absolutely. Absolutely. And it's funny how, despite the complexity of this kind of human information capture increasing with multimodality, and especially when we're thinking about some of the applications that we're going to go into in a moment, the existing problems of basically being able to organize your data, being able to effectively distribute it, having it be auditable, and having those kind of logs of who's been interacting with it. These are all problems that we've been solving for a while, but now just translates to this kind of advanced problem here too. Definitely time that we dig into how this specifically applies to physical AI. So Jen, we now have a kind of more like open representation of how these systems are set up for this kind of human supervision of AI agents in the physical world. Can you talk us through what we're looking at here?
Yes, happy to. So this is just a generalization of the many different conversations we have had with physical AI partners, but I think it captures some key elements in what we're seeing. So we're definitely seeing that video, audio, and text are really important modalities. The video often takes different forms, whether it's surveillance within a factory setting or the sensors, the visual sensors actually embedded on the robots themselves. So perhaps it is more of an egocentric view, and it's the view of the robot going through a physical environment. So we see some diversity there in terms of what the video looks like. Audio is also very important to pick up some additional cues from the environment, particularly in factory settings where some of these audio cues can indicate the status of the environment. And finally, there's a range of different texts that also might be really valuable here, whether it's instructions that are given to the robots, a safety manual, additional context and grounding that they need to be able to refer to as they take their actions. We're seeing all this interesting kind of multimodal data input be the base input that is really needed for these systems. And then when we look at the systems themselves, whether we call them AI agents or we consider them to be the robots, the droids, the physical AI systems themselves, we have them taking actions, making action proposals, but oftentimes what is required in learning or sometimes even operating in real environments is that importance of having the supervision layer, that human supervision layer at that point to guide a direction, choose or slightly adjust a decision. And that can then lead to the action that is actually taken in the real world. Something very useful here too is that this human feedback isn't just something that is useful in the moment, but it is useful feedback to your AI system for continuous learning.
Absolutely, yeah. So it's not just that purpose on the supervision side, it's also adding that extra kind of feedback loop layer that can then be integrated into the training protocol as well. Awesome. So I think the moment has come to jump into some live demonstrations, and so we can jump into a few cases of how this looks on the Encord side and how we're able to display and solve for these different problems. Fantastic. So what we will do is we will start off with an example of a robotic arm, right? So we can see in this video and in this interface, we're able to see our arm moving some pillows around the sofa, like so. This is from the Droid dataset, if anybody is interested. And you can see in this example that we're able to view our timeline at the bottom. And what we want to do to be able to, and I think we touched on when we were looking at the world model architecture, that we have this language base, right? We have the language base and we're importing this kind of sensor information. And what we need to do is we need to be able to allow our model to be able to contextualize from this visual space into the text domain. And so we can see in our timeline at the bottom that as we are investigating through these tasks, we can say, okay, it's move one pillow and then move the other pillow. And so we can see as we go through, if we want our model to be able to plan and reason, then what we can do is we need to find the kind of temporal elements and say, okay, great, let's identify once the pillow has been moved, we can select this portion like so. So we could say, pick up the white pillow and move to the right-hand side of the sofa. And then you can see that we can add these different stages all the way through our timeline here, like so. So as we move through, we can then say, yep, as we kind of continue here and then say, do the same for the patterned pillar. And then we can kind of continue and say, okay, maybe reset to base state. And now this is like fine for entering this information. We want our humans who maybe have this context to go in and capture this top level field. But then what we can do on top of this is leveraging the data agents. As you can see from this view, we're able to actually trigger this agent that what it will do is expand the semantic breadth of these captions that we have here in the bottom. So the way that the way that this works, this will take the frame, and then it will also take our two kind of contextual windows, and it will basically convert this text and like add extra rephrasings in there for our humans to validate live, and then see, brilliant, here we go. So do the same for the pattern pillow has now been expanded to move the pattern pillow to the center of the couch and place it on the sofa and set it on the couch. So I'm given these like kind of synonyms or rephrasings to be proposed, and then I can go in and make the corrections and as a human make sure that it matches the instructions.
And Oscar, I'm curious, what are you hearing from the conversations you've been in for why this kind of semantic breadth or diversity in these instructions is important?
Absolutely. Yeah. So the reason why this diversity is so important is that different humans who are interacting with these systems might prompt the problem in very different ways, right? And if it's only been labeled in one kind of uniform fashion and each task has only been given one specific instruction, then and that's why it's phrased in this way of this semantic breadth, right? That it's like, okay, I need multiple different people from different backgrounds and maybe non-native English speakers or from different languages or whatever that basically need to be able to interact with these models. And so we need to make sure that that has different kind of phrasings and context given to each of these. Fantastic. Yeah, and then we can also see that if we do want to, we can also interact with the actual objects themselves, right? So we can say, okay, pick up the white pillow and move it to the right-hand side. We also have the ability to go and label the specific objects too. And so if we wanted to be able to annotate those, and we can add them in the same kind of spatial domain too. And so we're able to kind of correspond this language with the physical world, and we're starting to really expand this into this kind of multimodal setting. Awesome. So for the next example, we're going to think about slightly different application, and we're going to think about a less physical agent. However, when we're thinking about this context where we have a credit card refund agent that's going to be taking a call from a customer and a support agent, then basically making a recommendation on the best practice here. So you can see that what we have on the right-hand side is we have this audio file. So this is actually a transcript from a conversation that we've synthesized. And so here you can see that this is a conversation between two speakers. We have this diarization and transcription piece. And so we have this transcript that's pulled out a segment. And so our agent ran in the workflow, pulled out this specific segment, and we can see this example highlighted in our text field here as well. And on the left-hand side where we have this actual like flow set out by our agent, and so the different kind of stages in that chain of thought reasoning, we have all of these different kind of assertions. And what we want as our human annotator to make sure firstly that the agent's made the right decision. And we can see on the left-hand side that we have this ability to flag any errors and then approve overall whether or not this is correct. And so we're able to actually kind of go through and identify as a human Are there any breaks in the logic? And if there aren't, have I basically pulled all of my information from sources? I haven't hallucinated, I haven't guessed, I haven't gotten lucky. So we can see here that we have, it's a $78 and we have $78.45 matching there. But as we move through, maybe we see this, for example, $15 to $200 range, and this is insufficient, right? So this might be something that's too broad, too far out of scope. And so we want to be able to annotate these specific fields. And so the way we can do that is we can say in our PDF file, okay, let me highlight that like so. I can go in there, I can highlight this, and then I'm able to flag that this is where my agent has made the error. And I can reject my agent's decision and then save this in here like so.
Oscar, one thing that this makes me wonder is it's really cool to see an example of these different modalities set up like this. What are you hearing from customers or partners for how they think about designing the interface for multimodal tasks?
Yeah. So when we kind of speak with various different customers, there are ways of, and part of the core problem here, right, is being able to display information from various different sources in a way that's helpful to these humans, because the way that models ingest data isn't the same way that humans ingest data. Was having a conversation yesterday in a client where I was talking that humans are very poor at reasoning over multiple frames of a video. You know, if you just give them a sort of individual slideshow of those, they aren't. Whereas models will, that's the way that they ingest them and they process that temporal information as a sequence, you know, and so being able to see the differences between them. And so being able to customize how we present these interfaces here and so have these different layouts where we can have videos, where we can have audio files, we can have these documents in here as well. Is basically designed to make this human context gathering as smooth as possible.
Really interesting to think about what designing multimodal inputs for humans versus agents should look like.
Yeah, absolutely, absolutely. It's a super interesting use case that kind of that's definitely one for that will only see grow as these use cases kind of expand as well. So it's very cool.
And how do you customize how this looks on the Encord platform?
Mm. Yeah, so the way that this works is that you can effectively just provide just a schema. So you can say, oh, here's some metadata, use this to tie this together, and then you can arrange these nice layouts with loads of different scenes. We've seen cases where we've got like 8 different inspection angles from a specific product piece in one frame as well. So it can be very cool and it's very smooth as well. Awesome. I think I see some questions filtering in the chat, which we'll definitely get to after the next demonstration. So we can see in this case, we have a multi-step reasoning setup. So the way that this works is that this is basically where we have, it's probably similar to that video example that we just discussed, right? Where we have multiple frames from a scene. So we're actually looking at an ADAS annotation workflow. So here we want to do that same kind of stage reasoning and step planning that we have, but then we want to pass this to our human annotator and then go through and review this. So what we've done is we've basically got this first stage plan where we'll have our assets that will be passed to a model. The model will look at the frames and then given the frames, we'll identify the right place to place a specific description for an action, and so to plan the next stage in the drive. And so you can see that this model is now running. I've just got this running in the background here and is basically passing through these videos and sending them through for human annotation in here. And then as my annotator, I can go in and I can start labeling and I can see, great. Now in this setup, I have the ability to view my video as we did for our robotic picking arm. Then I also have all of these actions here on the right-hand side. And so you can see that there, I'm able to basically expand these. And so I can see, okay, my first action is being able to view this. And then also in my timeline here at the bottom, I'm able to see these different action points as they change through time. So when you say wait at the pedestrian crossing while people cross in the market to crosswalk, and basically we want to make sure that a car isn't going to pull out until it's safe. We can expand this and extend this for the relevant temporal range. And you can see then that we can extend this to our piece like so. And then there where we have our next caption, we have no change, hold position, and either we can extend this, or because there's no change here, we can just delete this and continue our range. And so we're basically using our model to do the planning, and then we're having our humans to go through and validate the temporal information in this layout too. And similarly, we're also able to call on external models. So we can actually rely on some good old fashioned ML too. And we're able to kind of call out to those external models in the UI and use that to do some labeling too. So for example, if we wanted to use SAM2, then we can leverage this to annotate our individual people and pull them out in the scene too and have this kind of physical and planning context together.
It's great to be able to work with all these different kinds of models, whether it is a segmentation model as you're showing, or an LLM or a VLM, or maybe one of these any-to-any models soon as part of your workflow. I'm curious, Oscar, from the conversations you've been in, what models have people been raising? What are people using right now in the physical AI space?
Yeah, it definitely is. Comes from a huge kind of wide range, right? So a lot of it comes from getting some kind of model that will then map it into a common space, and then basically we'll use these sort of architectures like leveraging the LLM backbone to then process this information and then progress this into an action too. But I know that a bunch we set out at the top of the call, so we're seeing things like kind of Genie 2 being used to like process these actions where we're going from the situation and into the final action too. But then in the actual annotation process for humans, we can also leverage pieces such as like YOLO or whatever else. So we can see if we wanted to call YOLO from this example, we can use this to basically call out, bring in these predictions, and then label like so, right? So this can be a kind of as simple or as complex as required for the specific task. And this is really how we're like kind of mapping this like stage planning and chain of reasoning with the physical AI space around us too. So we're able to do both of these in one setup. Awesome. So I think the only remaining piece is to cover any questions here. So that was the end of the kind of demonstration portion. I see that we have a few in the chat. The first one covering, are we recording the meeting? Yes, this will be distributed afterwards as well. But we've heard a lot from me, and there's a question around Jen on the actual training side. And so how we're going from training the kind of individual models and then aligning them through some kind of shared layer. I know we showed the world model architecture earlier and discussed this LLM backbone, but I know this is something that the team at Encord are also especially interested in. So yeah, tell us what that looks like.
Yeah, I can imagine there will be some exciting announcements in the months to come. But to this question about different approaches to working with these different modalities and models with these modalities, there have been a number of ways people have approached doing this alignment. So it could be in the embedding or encoding and decoding space. It could also be in the models themselves if you wanted to build a layer to support communication between the models, such as the MCP that has been raised. But I think there are some models that actually have been trained with multimodal input in at the same time. So I think it's worth going to that Hugging Face blog post. It's called Vision Language Models, Better, Faster, Stronger, to learn more about those different training architectures.
Fantastic. Also saw a question earlier on about the GenRL graphic, which is a specific world model that we were referencing for that previous graphic, just to clarify on that one. And then I see a question about Edge AI CPU NPU that you support. So basically, when we're thinking about interacting with these models that we've shown here, These are deployed in an array of kind of different setups depending on the models and how they interact. When we see clients using these, they also use model on their own hardware and their own infrastructure. And especially when we have some of this kind of more sensitive data across these different domains and agents acting in different spaces, then this is really important. And like data security and privacy is at the core of what we do as well. And so making sure that when data is being moved around, that it's done in a safe way and that only the right people have access to it as well. Awesome. Absolutely. And I'll also post the link to that general paper in the chat too. So everybody should be able to see that as well. Fantastic. Well, this has been a great session. Thank you so much, Jen, for joining. And thank you, everybody, for your interest in physical AI and world modeling. And yeah, if you have any further questions following the webinar that come up, please don't hesitate to reach out to us. And so, yeah, from Jen and I at the Solutions team, thank you so much, and we'll see you at the next webinar.